Welcome to this installment of Secure Your DNS, Secure Your Network. My name is Tim Rooney, Director of Product Management at BT's Diamond IP Division, and the goal of this video series is to break down into bite-sized chunks the myriad ways that the domain name system, or DNS, can be attacked or manipulated for nefarious purposes, and to discuss defensive measures you can take to help secure your DNS and thereby better secure your network. In this video, we'll discuss trust sector deployment, in other words, how to deploy DNS servers in a manner that is akin to the philosophy of trust zones or security zones that you might have heard from a general security practice. And really the goal there is that should an attacker be able to infiltrate a server or element within a particular zone, that they are, in essence, restricted from exiting that zone. So you kind of have a contained policy that should one level of defense be breached, you've got another layer there to help protect outside of that trust zone. So we call it trust sector because the term zone really refers to the delegated portion of the domain tree as a zone. So we'll use trust sector as the terminology here in this discussion. So if we look at generally as a DNS administrator, what are the kind of the flows in and out of your organization? And if we look at going from left to right in the figure here, we see internal clients. These are your users on your network, whether they be employees or customers, subscribers, etc. So they're using various devices, and they're basically attempting to access internal information, perhaps on your intranet, maybe browsing the web or doing research on public websites. So that's kind of going left to right. And then you've got also external users, whether they're external resolvers or DNS servers themselves, actually trying to get information about your public web presence, your websites, your email servers, other IP applications that you make available on the internet at large. So that's kind of coming from right to left, and really just to illustrate that and kind of break this down into the elements that are involved, we have the caching recursive servers. These are the servers here. You see the arrows going into these caching DNS servers, and these are servers that are responsible for building up a cache of resolved information that is retrieved from the internet. And it's typically a good idea to have a few of these for redundancy, but also not too many. Keep it restricted so that those connections going through the firewalls there, we see this DMZ in the middle, the demilitarized zone, again, a kind of common security architecture where you've got externally exposed elements, DNS servers in this case, and also through which is traversing these queries coming from our caching servers and the answers coming back. So that's really one element. You've got the external authoritative servers. So again, these are the servers residing in the DMZ, so they're exposed to the internet, but you've kind of got a protection there with an inside firewall, at least logically, to protect that further penetration, if you will. That's in essence a trust zone of itself, from accessing the internal network information that you don't necessarily want to publish. And then you've got the internal authoritative. So by authoritative, we're really talking about a server that has authoritative information, in other words, published by the domain or zone administrator, and it's able to provide that answer because it's authoritative or responsible for that aspect of the domain tree, that zone within the domain system. So we kind of look at this from a different perspective. We're going to kind of name these four trust sectors, and in terms of their query source, where's the query coming from, left to right or right to left, and what's the scope of the query, and that's contextual based. So an internal query source, somebody inside your organization querying for something external, well, they're going to go through the recursive server, through the firewall, through the DMZ, to the internet and back. So we'll call that the recursive DNS trust sector. And then you've got internal users, again, querying for internal information on your intranet, and we'll call that, creatively enough, internal DNS. On the flip side, if you've got a query coming in from external to the organization, so this is somebody from the internet perhaps, querying for external information, and external in this sense meaning your information about your resources, but externally published. So you certainly don't want to necessarily publish information about your intranet sites where you have sales or pricing information, personnel information, etc. Don't necessarily want to make that available to those outside of the organization on the internet. And so the external DNS is, in essence, a subset of the DNS that you want to publish that is applicable to those accessing your website, email servers, other public IP applications that you want to make available. Now, the last quadrant here in our table, external for internal. Typically, as I was just reviewing, you don't necessarily want to publish information about your internal network on the externally accessible network, namely the internet, but we'll call it extranet DNS, meaning that in such a case you may have partners, suppliers, etc., who need to access information about perhaps your inventory or whatever you're making available to them through your partnership, and they may not have access to a lot of internal information, but a set of internal information that you don't necessarily want to publish on the global internet, but that you want to publish externally for your specific partners, and therefore we'll term that as our extranet DNS. So these are the breakdowns of our basic 4 trust sectors. And so again, looking at the recursive side, it really encompasses these caching servers and then the traversal through the DMZ. And here's really where your internal and inside and outside firewall can play a role in helping to secure that trust sector as well, in terms of allowing only outbound DNS queries from these caching servers. Not just anybody can issue a query. That kind of restricts the generation of DNS traffic from within your network. So again, you're kind of controlling it to a limited set of IP addresses or subnets. And then likewise, answers coming back, you cannot receive any, should not accept any answers coming just straight out of the internet unless there's been a corresponding question if you can track that information on your firewalls. Our next trust sector, I really grouped together external and extranet, and really extranet might be more applicable as through a VPN, but it's really an external organization. But generally here, they're coming in through your external servers. You probably want to have dedicated extranet DNS servers to handle your extranet partners, just to keep them separate. That's the recommendation. The architecture would look similar, but you'd want to have separate physical servers, or virtual for that matter. And here we show the servers residing within the DMZ. We've also got our little balloon here covering this hidden master on the left, and the goal here is that you've got a master server, which is really the server to which you make configuration changes, you update resource records, publish new available IP addresses for web hosts or other internet accessible hosts, and then that is conveyed to your slave servers or secondary servers, which are then the servers that get queried. So we call it a hidden master because we're basically accepting queries from anyone, but that it's really filtering changes down to the slaves, who then can be queried through the outside firewall from other internet resolvers comprised of name servers or just regular resolvers. And then last we have our internal sector, which is the internal authoritative server, which accepts queries from the caching servers. Again, your internal clients, your devices on the left here, they're basically going to be configured with a single IP address, or hopefully 2 or more IP address for the recursive server. When they boot up, they get an IP address from DHCP typically, and we'll also get a DNS server address, and those DNS server addresses should be those of the caching servers, which can then filter out which queries are for internal versus external. So let's take a look at steps you can take to solidify these trust sectors, and really having independent servers for each sector is a good idea. Just obviously there's a recursive overlap there as I just described, but otherwise having independent functions where you don't have authoritative information on the recursive servers, unless you're a very small organization, maybe you have a couple DNS servers, but in the general case you want to have a separate DNS server, set of DNS servers for redundancy and availability, but set up for each different role or function. So the intranet information is published on your internal trust sectors, your internal DNS. You want to disallow access from external sources, so this can be done through ACLs on your DNS servers themselves, maybe through IP tables. Also various DNS applications like ISC bind allow you to define who can query what address space. So if it's just your internal private address space, for example, your IPv6 ULA space, you can encode that in as an ACL to disallow that access from external sources. You can also turn off recursion. So you want these internal DNS servers that are answering your internal information to be authoritative only. In other words, they're not able to recurse, not able to just say, accept a query from a client and say, go find the answer for me, which is basically how the recursion process works. You stub resolver or device issues a query to the DNS server, that recursive server goes out, figures out where that answer resides and queries to get that back. So you want to disable that process on your internal DNS servers, your internal authoritative DNS servers, so you're not mixing functions across different servers. You can sign zone transfers between the master and slave. So again, just securing that link and authenticating updates. You want to protect against the occasion of malware, for example, infiltrating your network and illicitly trying to update DNS or gather DNS information. So through the signature process, you have a layer of authentication there to information going between your DNS servers. Allowing notifies and zone transfers only among masters and slaves. Again, you want to kind of constrain that to your set of DNS servers. As certainly part of the security policy should be to inventory all of your DNS servers that are running in your network. That should be defined as part of your plan, your network plan and network management, and that should also govern the communications, setting up these ACLs to define who can notify who can zone transfer among themselves, and also with the hidden master configuration, be able to set that up between the master and the slaves. And really, hiding the master really comprises of removing that master from the name server resource record set that you publish for the zone, and also removing the mname master name field setting of that master server to one of the slaves in your start of authority or SOA record for the zone. So setting the mname to one of the slaves, also removing the master from the NSRR set for the zone is the mechanism for hiding the master. And it really is just another way to make it more difficult to locate the master, because again, once an attacker identifies the master, they might be able to infiltrate the master, make changes to configuration, otherwise wreak havoc. You want to prevent administrative access to all of your servers except from the management IP space. So if you've got separate management VLANs, certainly don't want to allow SSH access from another address space at all. You want to inhibit exposure to the server implementation. So sometimes you can run you can run a dig for version.bind chaos text record, basically just a way to issue a query to a DNS server to find out what version of bind it's running, for example. And that can be used by an attacker to identify vulnerabilities that might exist in that version of bind and try to exploit those. So you want to try to hide that information. It's really not necessary. Again, with your inventory of your DNS servers, you should track that out of band. Secure the server. We've got separate videos on individually about securing the server, protecting against DDoS attacks, also DNSSEC. Now, DNSSEC internally to authenticate the DNS information as valid. So we move on to our next trust sector, the recursive trust sector. So this is really, again, where your clients are querying those recursive servers and they're going out to the internet in order to track that information down and provide it back to the resolvers. So for your recursive servers, you want to allow recursive queries only from your network. So if you're running totally private space, ULA space internally, you want to govern your ACLs perhaps through IP tables again. If you're running Linux variant, or also on your DNS application, various DNS server products allow you to set up the ACLs from a DNS server perspective. So it's a good idea to do both there if possible. So allowing queries only from either clients themselves or from, if you've got forwarder DNS servers as well. Also allow access to the cache. Certain applications like bind allow you to allow query cache. Keep that restricted also. Allow recursion queries and access to cache only on the server interface possessing the internal IP address. So in a case where you do have recursive DNS servers with multiple interfaces, let's say you have a physical interface that is almost, it is connected network-wise to your internal network, and then perhaps a different interface is kind of outbound facing that DMZ internal firewall. So this would be an additional way that you can physically separate in terms of the interfaces, inbound versus outbound traffic, and not allowing inbound queries coming in from the external interface on the physical side. Prevent externally spoofed addresses. So if they try to get around that by spoofing addresses, you want to implement the address filtering using reverse path forwarding. Good approach there. Disallow dynamic updates and zone transfers. Again, certainly don't want to allow anybody to update a recursive server. It shouldn't have any zones on it per se. except for DNS firewall zones, RPZ zones. But you want to disallow that to the extent that any other zone, you don't want to allow that. So you might want to just allow those updates from your firewall service or from an internal system that you're using to update response policy zones. Prevent administrative access, again, from except from your management VLAN. Inhibit exposure to the server implementation, as we said. Secure the server. From a DDoS perspective, defining query rate limits. So again, you've got all your internal clients hitting this recursive server. You want to be able to restrict how many queries can be outstanding for a given client, and also how many queries the recursive server has outstanding for a given question that it's asking. So you can set quotas up on that on various implementations. And then configuring DNSSEC validation is recommended in terms of for those zones that you're querying for information and the information that is signed. It's a good idea to try to validate that so that you're giving an authenticated answer response back to your resolvers. Again, DNSSEC at this stage is only about 15 to 20% deployed, but as that number goes up, the recursive side, the validation side is relatively simple to accomplish and implement, so we would recommend that. If it's not signed, it just goes through unscathed, so to speak. And then configuring the DNS firewall, I alluded to this earlier, and we have a whole separate video on this, but basically it's a way to determine, based on the query and the response coming back to the query, you can actually apply a policy to either drop the response, change the response in some way, or pass back a not found response. So this gives you a way to protect from malware trying to communicate to command and control centers. Now if we look at shifting gears now to our external trust sector, so again, these are the DNS servers that you have configured with your external authoritative information, your web servers that you want to put out on the public internet, your email servers, etc. So for these servers, you want to disallow recursive queries altogether. There's no reason anyone should be able to just query the server and say, hey, go find the answer for me. It should be, here's your question. If I don't know it, you're not getting any answer back, basically not found. So disallow recursive queries. Open resolvers have been found on the internet that can be used for nefarious purposes, so you don't want to participate in that. Just disallow recursive queries on those servers. You want to assign zone transfers again between the hidden master and through that internal firewall we showed a little bit earlier. Again, just to authenticate those, allowing notifies and zone transfers likewise, again through ACLs on the DNS application. On the master, allow queries only from the slave's private IP addresses. So the slaves do need to query the zone for any changes to refresh the zone. But these are the only IP addresses that should be allowed to make those queries, the IP addresses of those servers as you've configured them and as you are inventorying. Prevent administrative access, again, from your management LANs. Inhibit exposure to the server version, secure the server, defend against DDoS attacks. Well, we've got a whole other module on that, as well as another module on reflector attacks. And if you disallow recursive queries, you're going a long way to helping resolve reflector attacks. But there's other response rate limiting type policies you can set up to also further mitigate that type of attack. DNSSEC, again, it's really an area where I think a lot of folks have shied away from for its purported complexity, but a lot of the vendors have implemented a lot of tools that go in to automate the process, so it is much easier these days. So if you haven't looked at DNSSEC in a while, I invite you to do so. It's just a way to help make the internet more secure by authenticating your data. So independent of some of the newer things coming out with DNS over TLS and over HTTPS, which secure the actual transaction by encrypting it, DNSSEC provides a different layer of authentication of the zone information itself. So just an added layer of protection there. Supporting encryption, as I just mentioned, so these two are complementary in my view. DNSSEC authenticates and also provides a data integrity check, and encryption, of course, disallows eavesdroppers from viewing DNS transactions going into your DNS servers and out. Now, if you are using a hosted DNS provider, so the case I just went through was really where you're managing the DNS servers. So here, where maybe you've outsourced your external DNS to a service provider, so some of the things to think about there, make sure you've got a unique per user login and not just one for your whole account. You want to be able to have accountability of who's making what changes, making auditability to be able to review that. should anything happen that you need to go back through logs and review that. Certainly you want to use encrypted connection to make administrative changes. Access logs, as I alluded to a second ago there, need to be able to be reviewed and audited. You want to make sure they do support DNSSEC signing and also the ability to automatically roll over your keys, and also an emergency rollover support plan should your key, their key, basically that they're using on your behalf, get compromised. You need to at least have a plan in place that they have a procedure to do an emergency rollover. And then also you want to check into other security features that they provide. Anycast provides a great way to really distribute the query load for your external information across the globe. So look for Anycast global deployment there. ACLs, this is really something that they may not want to share with you all the details, but certainly you want to make sure that they've taken the steps to secure their DNS infrastructure. Geographic resolution, providing a closest resolver answer is a good thing as well, and response rate limiting can cut down on reflector type attacks. Obviously you want to look for a solid service level agreement, so in addition to included with that the DNSSEC emergency signing, you want to look for service availability type arrangements and any kind of notification of security breaches. DNS denial of service mitigation certainly is important. Parent domain, which is typically going to be a .com or .org or .net, a TLD, a top-level domain. Also, you want to make sure that your provider's relationship with the TLD registry is there's security controls in place there. There is a domain hijacking vulnerability, which if somebody does change access to TLD and modify records, you don't want them to be repointed somewhere else. So again, just make sure that they've got controls in place and a vulnerability notification process. And then really you want to consider using either multiple external providers if that's your strategy, or even using an internal in-house deployment and coupled with an external provider or two or more. And then really the goal there is to provide diversity, of course. You've got more servers serving up your external namespace, so should one provider be attacked, you've got a backup using your own or another provider's DNS servers. On the extranet side, this is really our final trust sector here. That's really, again, where you've got a partner, for example, accessing limited information, internal information, but accessible by an external organization, so someone outside of your organization. So you want to really constrain this within somewhat of a DMZ type environment, as we saw for the external users, but a separate external DMZ for just your partners, just because they do have access to different information, more information perhaps, and you want to keep that constrained and cordoned off as a separate trust sector. So you want to have that coming in hopefully over a VPN. You want your partner to access the VPN gateway, so allow queries only from the VPN IP address space. Publish resolutions in your DNS servers only for the internal hosts that are required that they need access to. Disallow recursive queries. Again, you don't want to be chasing down queries. Just provide authoritative answers. Sign your zone transfers for the configuration of those servers supporting your extranet. Again, allow notifies and zone transfers only among those servers you've defined. And also on the master, allow queries from the slaves. A lot of common rules here, as you see, which is a good thing because you can apply simpler policies across multiple trust sectors. Prevent administrative access from outside the management VLAN. Inhibit exposure to the server implementation. Secure the servers. Defend against DDoS and reflection attacks, and then if your partner supports DNSSEC, it's a good idea to sign and authenticate that information. So with that, we've gone over the various trust sectors that we've defined and recommend that you deploy your DNS servers in accordance with this trust sector architecture to enable you to add a layer of defense should, in addition to these individual considerations we've covered, but also once they've if an attacker should compromise a given server in a given trust sector, they will be constrained to that and not be able to do further damage. Thank you very much.